So all of the gas problems we have talked about so far have dealt with pure substances, meaning just a pure sample of helium gas or a pure sample of hydrogen gas or a pure sample of carbon tetrachloride. But many times, many common substances that are gaseous are mixtures of gases. Air, for one, being a very important mixture of gas. Air is really a mixture of nitrogen, oxygen, carbon dioxide, a little bit of argon. So because gases can be mixtures, it's important to talk about how these gas laws apply to mixtures of gases. 2 points to recognize when dealing with mixtures of gases. The first being is that mixtures of gases are defined by Dalton's law of partial pressures. All that means is that if I have a mixture of two gases, the pressure of that total sample is equal to the sum of the individual pressures of the individual components. So let's say, for example, we have a sample of, let's say this is oxygen that has a particular pressure. We have a sample of nitrogen that has a particular pressure. If I add those two samples together, I not only add the total number of moles, but I add the total pressure. So the pressure of a gas mixture is equal to the sum of the individual pressures from the individual components of that mixture. That's the first law. Second point that refers to this Dalton's law of partial pressures, which is that many times when collecting gases in an experiment, we collect gases over water. This example is one, this example is an experiment that you do in Chem 1. It's actually a pretty cool experiment where you take zinc, dissolve it in hydrochloric acid, and you collect the product, which is hydrogen gas, by hooking up this tube to a water bath. This tube has water in it. When you produce the hydrogen gas, it bubbles through and displaces the water that's in the tube. And so therefore, this is a way to collect a product that is a gas from a reaction. The one thing to remember, though, when doing that is that when you collect this gas, you not only have hydrogen gas, which is a product from this reaction, but you also have water vapor. You have water vapor because you are displacing the water that is in the tube. So to find the pressure of just your product gas, in this case the hydrogen, you need to know something about the total atmospheric pressure, the pressure at which the experiment is done, along with the pressure due to just the water vapor. This total pressure, you can read it from a manometer, or it's usually given to you in the problem. The partial pressure of water, you can look that up in a table. For you guys, it will be given to you in the problem. But the second and final point to make about mixtures of gases is that when you collect a product gas over water, to find the pressure associated with that gas, you need to take the atmospheric or the total pressure and subtract it from the partial pressure of water, and that will be given to you as well, and then that will give you the pressure of your product gas. So in a subsequent video, we will do an example involving an experiment like this, where you will have to use this law of Dalton's partial pressures to determine the pressure of a gas sample.